welcome to this tutorial on custom work coordinate systems, ViewSheets, and how you could program this entire part with different tool groups and have it set up to post out one operation or post out all operations with different work coordinate systems. So you could do progressive machine work with like 3 different vices. So you get the top, bottom, and then this side feature on this part. And in the description, I also have a link to download this solid model so you could follow along if you like. All right, so first thing I want to do is we're just going to go into our planes tab here. And if you don't have that open, you can go to your view and then turn on your planes. And then for this first plane, I'm going to click the plus sign over here and go down to dynamic. And I want to snap it to this corner here. And make sure the line's highlighted, then it'll snap to the edge of that. And then we also need to adjust it so it's lined up to this left edge as well. So if you grab your x-axis here, this line, and drag it over, and you could snap it to that line. So now we're on the corner of this part, skipping the radius. And I'm going to click OK on that. Actually, let's name it something. I'm going to name this... Sorry, I went into Fusion for a second. So this is going to be called Op1. And then I'm also going to turn on work coordinate system in the set as, and then work offset, I'm going to put number 1, and then go ahead and click OK on that. And then I'm going to right click on the screen, go to isometric, and I'm going to click fit. And then on our view sheet, I'm going to save this view sheet, right? Okay, cool. So now let's set up a work coordinate system for the bottom of this part. So if I flip it over, try to get a good angle here. So that's our op1. So let's pick this corner for our operation 2. So I'm going to click dynamic on our planes, then select the kind of the same area here, and then you'll notice our Z is pointed in the wrong direction. So if you select the inner thingy, you could rotate this over 180. And quick tip here, inside this ring, it'll snap in 5-degree increments, and then outside the ring, you're free to set the angle that you like. But I'm going to go ahead and set that to 180. And then I'm also going to set the X to this line right here. Okay, cool. And I'm going to name this Op2. And I'm going to set that as a work coordinate system. And click OK. And then select the isometric. And then I'm going to click the plus sign next to our view sheet, right click, and then, view sheet 2, there we go. Save view sheet as bookmark. Another thing is edit, and then I'm going to set auto, and set that to work offset number 2. Okay, cool. And then the last work coordinate system we need to set up is for the side of the part here. So same thing, plus sign, dynamic. I'm going to snap to this edge here, and then drag the X over. And then I'm going to set that to number 3 before I forget, and then call this Op3. And I'm going to select OK. And then I'm also just going to right click isometric, click the plus here, and then save view sheet. And we can rename these as well. just right click and rename. So put op1, rename, op2, rename, op3. Alright, cool. So now if I click op1, we're in this display here. And you could also notice that it sets your, sorry, I have the auto hide feature on the taskbar. So our C plane is op1, T plane is op1, and our work coordinate system is op1. And then if you go to op2 view sheet, it switches it all over to construction plane 2, tool plane operation 2, and work coordinate system 2, and then it'll also do the same for 3. So that's a good way of kind of easing your flow when you're programming this part all the way through. Because then if I just click this one, we could just program off of all this, right? So let's go to machine, let's go to mill. I'm going to do a default mill. And then let's go to our tool paths. So now I'm going to set up our stock. And I'm going to select add bounding box. And then I'm just going to select the cursor next to manual, select our solid model, and select OK. And we have our auto-generated stock. And then in our toolpath group, I'm just going to double click this and put op1. And we can go ahead and collapse that. So in operation 1, we're going to want to, we're going to do a face mill. And then we're going to have a 1/2-inch cutter do our contour, our pocket, and then also our bores. And then we need to clean up this pocket with a 1/4-inch end mill to get the radiuses. And then we'll also put a deburring tool. So we can go ahead and go to our tool manager and we could set that all up. So if we right click, we can create a tool. And I want to start with the facing mill. I'm going to put 1.9 by 2. And then I'm also going to put a corner radius of a 1/16. That's fine. Oh, let's go back into that and edit it. So let's edit the tool. And then if we go into finalize properties, we could have it just do our feeds and speeds for us, so we don't have to adjust it in the actual tool path when we grab the tool. It'll just always be that. We'll just put 6 flute face mill or something. For the feed rate, let's go ahead and put 60. And then our spindle speed, we'll just move this at 4 grand. And we'll just go ahead and leave all the labels the same here. And I'll click finish on that. And then right click, let's create another tool. And we'll do our 1/2-inch end mill. And we'll say it's a 3 fluter. And for our feed rate, I'm just going to put 60 and 7 grand. And then you could also populate these fields too, but we'll go ahead and just do those in the tool path. Right click, we're going to create a tool. We're going to create our 1/4-inch end mill now. We'll just type in 250 finalize properties and we could enter what we want. We'll spin this at 10 grand and we'll go 40 on the feed. And I'll just go ahead and click. And that'll also be a 3 fluter. Click finish. And then create tool. And we're going to create a chamfer mill. And we'll just say we have a 1/4-inch chamfer mill. Our diameter. Oops. Not 25 inches, 250 inches. And we'll say our tip is 30 thou. Finalize properties, and we'll just say this is a 2 flute chamfer mill. and we'll go ahead and put in our feed rate. We'll just do 60 at 10 grand. And we'll click finish on that. And then the other features on the side, we have a 201 drill, number 7 drill, and we're gonna do a tapping cycle on that as well. So we'll go ahead and create those tools. So let's go ahead and drill. Oops. And we're gonna set this as 0.201 and finalize properties. We'll just do some conservative numbers here. We'll do a feed rate of 20 and spindle speed of 2 grand. So I'll click finish on that and then create tool. And we're gonna create our tap. So I think the standard tap it gives you is a quarter 20. So our nominal diameter is 250, threads per inch is 20, and I'm going to set that as a plug tap. And 1,000 by 50 feed rate is fine for this. Let's see, the pitch is 50 thou, so 50 thou, so feet per tooth is 50 thou. Perfect. And tap cycle, we'll just set that to rigid tapping. Cool. So now we have a tool library for this, and you could actually save these and bring them up for different parts that you're going to program. So say you have a tool list and it's already in the machine, you could just call this back up and just keep reusing these tools. So we have our tool manager set, and I'm going to go ahead and close that. So let's do a face. I'm not going to select anything. We're going to go off the stock. And then so this is going to be tool 1, and then you can see it auto-populated our feed and spindle speed. Linking parameters. Well, let's go to cut parameters. Let's look. And I want that to be zigzag, and I don't want any stock left on the floor. I'm just going to set all these to 55%. 55, 55. And then step over 75% is fine. Shouldn't be taking too much material off. And I'm going to go back to linking parameters. I'm going to set this all to absolute. And for depth, just click the top. It should be 0, right? And then for planes, you can see that it auto-populated our WCS tool plane and construction plane to all op1, which is what we're working on, right? So I'm going to click apply and OK. And just for demonstration, I'm going to go back to the stock, and I'm just going to add 100 thou to our dimensions here, so we could see it actually machine. Alright. And then I'll just click regenerate on that. Alright, cool. So next thing we're going to bring out is our 1/2 inch end mill, and just do a contour and then pocket and circle mill. So let's go ahead and do a contour. And I want to highlight that bottom contour there, just so it gets our depth. I'm going to click OK. Tool. It's going to be tool number 2. And see, it's pretty cool. So it generated our feed and speed for us. Then cut parameters. I always like to use where. Compensate to the left, sharp, yeah. And we don't need to edge break this because it already has radiuses on the geometry. Lead in, lead out. That's a bit extreme. I'll just go ahead and put 25%, 55%, 90-degree sweep, and put that to our exit as well. And then enter exit at midpoint and close contour is good. And we'll do 100 thou step over. And then for our linking parameters, I'm just going to set this all to absolute. and then for depth, it already picked up our -1 inch. So click apply, click OK. We can see we have our contour here, and then we'll just go ahead and do a pocket tool path. We'll select the inside pocket here. I'm going to select OK. Tool, I'm going to go ahead and select our 1/2 inch end mill once again. We'll go right to cut parameters, and for the walls we'll go ahead and leave a little bit for our 1/4 inch to come in and clean up, since we got to hit those radiuses anyways. And stock to leave on floor we'll leave at that 0. For roughing, we'll just go ahead and leave it at zigzag. 50% step over is fine. It's not that deep. We'll helix in. We'll just let it do its standard helix in here. And then for our finish, we don't need a finish. We're going to finish up with our 1/4 inch. So lead and lead out's also turned off. And then I'm just going to set all this to absolute. Depth is not -100. It is -1/8 of an inch. And click apply and click OK. So we can see it's going to spiral over, spiral down, and then just zigzag back and forth in that pocket. And then the next thing we need to do is our circle mill. And I'm going to do this big bore first. Tool, 1/4 inch. Cutting parameters, we're going to turn on wear, and 0 to leave on walls and floor. And then for roughing, we're going to turn that on. We'll leave a 50% step over, and then helix entry, we'll just leave it at the standard values. And then we're going to turn on our finishing. We want 1 finish pass, and spacing of 50 thou is fine. And we'll just do our finish pass at the final depth. And linking, I'm going to set all these to absolute. And then for our depth, I'm going to select the bottom of our bore there, which is 3/8. So let's go ahead and click OK on that. So we can see we got most of this programmed already. And then I'm also going to circle mill once again the inside bore. So let's go ahead and go in there, select our 1/2 inch tool, cut parameters, where should be the same, and then all of our values should be the same from the last time we did this, but it's always good to check. And we'll just go ahead and go down 1 inch, just so it's going to show up on the back side, and we don't have to worry about any material being left over and, you know, milling over like 10 thou of material. It's pretty noisy, so we'll just make sure it kind of breaks through that. So I'm going to click OK on that and click apply, and we'll just generate that tool. Oh, one thing we need to do on this is our top of stock, so we're going to select that. The floor of our wider diameter bore, just so it doesn't helix down so much. You could just get right into it. And last thing we need to do is go back and do our contour. And I want it to go the other way. Yeah. And our tool is going to be number 3, our 1/4 inch end mill. These values should be fine. Where all these values are good. Same lead in, lead out's fine. And linking parameters, top of stock is just going to be 0 there. Feed plane, we'll just set that to 100 thou. Select OK. And I really don't like where it started there. So I'm going to go to chain, and I'm going to edit this And I'm just going to select the dynamic feature and just select the end, kind of in the middle of that geometry. And then I'll just regenerate that. Now we can see that it's going to enter and exit in the center of this. Perfect. All right. Also, we need to regenerate our face mill there. So if I go to isometric again and right click fit, and I go to op1 and say view sheet, and then I hide all of these, it should come back with those on. No, maybe not. Maybe they changed that in 2023. I'm not sure. All right. So we have op1 programmed. Let's select our op2 view sheet. And this actually is not a good location for our work coordinate system. So let's just go back into planes, right click edit, and I'm just gonna take this and snap it up here. And then for our X, drag that over to the edge. That still doesn't look right. There it is. All right, cool. And then I'm going to select OK on that. Right click, isometric. There we go. That's much better. I'm kind of doing this on the fly, guys, so I might miss things here and there, but I'm just trying to give you the gist of it. And then when we go through verify, we're going to make sure everything's cozy. We don't get any plunges or weird toolpaths. So back in our toolpaths tab, we're going to right click here, and then groups, we're going to go new toolpath group. We're going to name this one op2. And for this, we're also going to do a face mill. Select OK on that. And it should have all the same parameters as last time we did this. So depth is 0, right? Okay. Let's select OK. And then now we have that. And we already did our contour, so all we need, we did our contour and we did our bore, so all we need to do is this pocket now. So let's go down, select pocket, select that inside contour of the pocket. Tool, we're going to do our 1/2 inch end mill, and all this should be the same as last time we did it. And depth is, yeah, 1/8 of an inch. Okay. Did I miss anything in this? I don't know. Let's go back to parameters real quick. Top of stock is going to be 0. Yeah. All right. There we go. And then same thing. We're going to select our contour. And then I'm going to reverse it and just go to our dynamic. Just put it in the center there real quick. Tool is a 1/4 inch. Lead in, lead out, it's all the same. So last time we did this, and our link parameters, depth should be the same. Yeah, and our top of stock is up there. Yeah. Okay. So now we have the top and bottom programmed. One thing I did forget to do is our chamfer mill, but we'll just skip that, I guess, in this lesson, and then I think I included that in our 2D contour video, so if you want to learn how to do 2D chamfer milling, then you could watch that. But we'll skip that for now. This is just kind of a demonstration of the power of ViewSheets and setting up your custom work coordinate systems. You know, doesn't look like it saved our location on this, did it? I'm gonna go ahead and edit that again. It's gonna make us regenerate this, but I'm not sure why it's not saving. Alright. Got that. So we're good there. Up to do. That's where it should be, right? Save our view sheet again. Toolpaths, it's gonna want to regenerate these because they're all based off a new work coordinate system, right? Okay, so we got op2 programmed and op1. Op2 is good. Now our op1 looks off. This is all op1. So metric, let's go back to our toolpaths and then I'm just gonna select this, generate. So we're good there, and just gonna save the view sheet again. So if I hide all that, collapse that, and then turn on these. I guess I must have set up our work coordinate system wrong the first time, but hopefully you made it this far in the video and learned from my mistakes. Kind of interesting. This looks right. Okay. And then let's right click and do our groups, new toolpath group, and we're going to call this op3. And all we do is drill tap, and then we're going to counterbore this. So let's go back to our toolpaths, and I'm just going to select the circle. I know it's big, but it's not a big deal. And we're going to go to tool number 5. We have our settings here, and cut parameters. We're just going to go straight through with the drill, G81. Basically, and if we go to our linking parameters, I'm going to set these to absolute. Retract, it's 100 thou. Our depth, I'm going to select the bottom of this, and let's do a tip comp, and I want it to punch through 100 thou. And I'm going to click OK on that. So we got that toolpath. And then we're also going to do another drill cycle, but we're just going to do the tap this time. Tool, we're going to do our quarter 20 right hand tap. Yeah. I'm going to select rigid tapping cycle for that. And then for depth, we're also going to do this. It's 1 inch, and we have our tool compensation on here. I'm just going to put an 1/8 inch. Sometimes the leads on the taps are pretty long in length, so I just want to make sure we get past that lead so it's an actual thread all the way through. So depends on your tap, but we'll just do it like that. And then for this counterbore, we're just going to do a where is it? A helix bore. And I'm just going to select the bottom of that counterbore. And for a tool, we're just going to use our 1/4 inch end mill. I'm going to turn on wear, and we're going to do 0, 0. And roughing, finishing. For a pitch, I'm going to put 40 thou. Feed rate at bottom, not 1,000, but 100%. And we'll just finish it upwardly. And we'll set the feed rate and spindle speed to 100%. So I'll just go in and back out. And for this retract, we'll just do 100. And I'm going to set all these to absolutes. Depth is, where is it? Having trouble selecting geometry today. So we'll go ahead and leave it like that. So it's negative 300. And we'll click OK. And then we can see we have our helix mill in and out. It looks a little funky, right? But it's just a helix in and then a helix out. So I'm going to go ahead and select our machine group and hide all our tool paths. And then if I go to operation 1, isometric, op 2, looks like our work coordinate systems are in the right place this time, and they kind of stayed there. I'm not too sure what happened with that, but let's go ahead and do a verify. And we should see the tools hit from 3 different angles. And make sure your tool plane's also with your work coordinate system, because if it's not, it's going to assume you're using multi-axis and try to rotate on an A, B, or C to get those tool hits. So just make sure your work coordinate system is matched up with your tool plane and construction plane. So we have our plane, contour, our pocket, our circle milling, and then side. And we're doing the back side of the part here. Drill, tap, and counterbore. Cool. Well, hopefully you made it this far in the video and you learned a bit about ViewSheets and custom work coordinate systems. And I'm going to go ahead and try to get another video out over the weekend so you can learn a little bit more on MasterCAM. So, all right. Thanks for watching.